Greetings everyone. I am Tejas Barhate, a third year engineering physics student at IIT Roorkee. Today I would like to discuss with you a topic related to signals and systems, which is energy and power signals. So let us begin. We will start by defining what is a signal. Briefly defining, we can say that a signal is a function that represents the variation of a physical quantity with respect to any parameter. For instance, the physical quantity can be voltage, which is varying with the parameter that is time in an electronic circuit, or the physical quantity brightness, which is varying with distance in an image. A signal, it can be a real valued function, or very well it may be a complex valued function. Moving on to the signal classification, these are the various types of signals, which are continuous time and discrete time signals, deterministic and non-deterministic signals, even and odd signals, periodic and aperiodic signals, energy and power signals, and lastly, real and imaginary signals. We will be focusing on energy and power signals as it is the scope of this presentation. We will start our discussion with defining the energy signals. So, firstly, what does energy signify? Energy is the measure of how much work can be done without consideration of how much long it takes for the work to be accomplished. So, for a signal denoted by f of t, the total signal energy E is calculated by either using the formula for the continuous time or the discrete time depending on the signal. So, after calculating the total energy content of a signal, the signal can be referred to as an energy signal only if it satisfies the criteria that the total signal energy is finite. Otherwise, the signal cannot be referred to as an energy signal. If f of t is a complex valued function, then mod of f of t square denotes the square of its magnitude. A necessary condition for finite signal energy is that the amplitude of the signal must approach zero as time approaches plus or minus infinity. In other words, we can say that the energy content in the tail section of the signal must approach zero, which is given by this limit. So the common cases for energy signals are, firstly, bounded signals of finite duration, such as a single pulse, and secondly, exponentially decaying functions. Moving our discussion to power signals. So mathematically, power is the derivative of energy with respect to time, and physically, power is the rate at which energy is being supplied or being consumed. As earlier discussed in the energy signals, if the total signal energy for a signal comes out to be infinite, then the time average of energy, that is the average power, becomes more meaningful. So the average power of the signal can be calculated using these formulas. For an interesting point to be noted here is for a non-periodic signal, the average spans over the entire time, that is from t equal to minus infinity to infinity, or n equal to infinity to minus infinity. But for a periodic cycle, it only spans for a single period cycle, because the average power of a periodic signal is equal to the average power in a single periodic cycle. After calculating the average power of a signal P, that is P, the signal can be referred to as a power signal if and only if the average power of the signal is finite. An interesting case we see is for an energy signal, it always has zero average power. So, summarizing our discussions till now, we can say that energy signals are those signals which have finite total energy and zero average power, whereas power signals are those which have finite average power and infinite energy. So studying both the definitions carefully, we can see that a signal cannot be both an energy signal and a power signal. It must always be either an energy signal or a power signal. But there are certain signals which are neither energy signals nor power signals, such as a unit ramp signal. Generally, periodic signals are viewed as power signals and non-periodic signals are viewed as energy signals. In our real world, most of the observed signals are energy signals because for a power signal to exist, the criteria would be Such a signal requires infinite duration and infinite energy, which is practically not possible. So this ends our discussion on energy and power signal. Thank you.